melody control captivates your party patrol. Your mind, body, and soul flow. The bell tolls like the rhythm explode. Big, bad, and bold beat.
Hi, I'm Juha and I'm a hockey player here at USC. I will be going through some physics concepts and examples with you this semester. And remember, just like on the ice, there's no such thing as luck in physics. Just keep your head up and work hard.
In this video I will briefly take you through vector addition. So the problem is, how do we add two vectors, let's say vector A and vector B together, and the resultant vector is called R in this case. So that we would be able to do that, the vectors have to be expressed in some kind of reference frame, and usually it is the x and y or xyz coordinate system, like in this case. And how do we express our vector A? It's always written in its components in this frame. So for example, vector A has length ax in the x direction, and we mark it like this. I hat is the unit vector in the direction of the x-axis, so its length is 1, and it doesn't change the length of the component itself. That is explicitly expressed by the factor in front of it, in this case the ax. Okay, so then the vector A has also a component in the y direction that is called ay, and the unit vector in the y direction is, as you may be well aware, is j hat. And the same thing with B. It has B component or x component and also y component. And then simply the resultant vector is achieved by adding the respective components together. So pretty much this is saying that if we want to find what is the length of the vector r in x direction, we have to add ax and bx, like is clear from the figure. So this simply becomes ax plus bx in the x direction, I hat, plus in the y direction we have to take the ay and by, and that is multiplied by j hat to indicate the direction in the y direction. Now that we have this general format for two vectors added together, the problem becomes, what are ax and bx, or ay and by, that is the components of these two vectors. If they are not given, they have to be calculated from the magnitude of these both vectors. So for example, what is ax? If we use simple trigonometry, let's call this angle alpha, then we know that ax is the magnitude of the vector A, which is the length times cosine of alpha. And in the same way, ay, which is here, the length of that component is the length of the whole vector times sine alpha. And in the same way, we define vector beta. This angle is always, we define angle beta. And this angle is always from the x direction, or the x-axis towards y direction, or in other words, counterclockwise from the x-axis. And in that way, like we did earlier, here we have again bx, so bx must be the length of the vector b its magnitude times cosine beta, and the y component, which is here, is magnitude of vector beta times sine of that angle.
We're going to take a trip back in time. Are you ready to get into your time machine? Okay, fasten your seatbelts. Are you ready?